Hello everyone. I am here to explain you the earlier video, that is problem number 2, in another method which is preferable method in the exam hall to save our time using concept of relativity. Okay, as we are aware of the question, there is a train. Suppose if this is a train and there is a person somewhere here. He had projected the ball and the ball moves in the parabolic path and lands somewhere else here. Okay, the train has some acceleration a in horizontal direction, which is actually our target to find. And now the difference between the earlier method and the present method is, earlierly I have done the problem using ground frame. I mean, completely I have done the problem with respect to the ground frame, but present method is with respect to the train frame, or I can say with respect to the boy. Okay, so if you question the boy, or if you are in the place of the boy, he can say that I was here when I projected with a 10 meter per second at an angle 60, and to catch the ball I ran towards the ball. To catch the ball I traveled 1.15 meter, which is been mentioned in the question itself. So with respect to the boy, or with respect to the train, to catch the ball he have to travel the distance 1.15 meter, which we can say as a relative distance 1.15 meter. Okay, and now to make everyone to understand this scenario, let me explain you detailed analysis as shown here. Suppose if this is the projectile which goes in the parabolic path and lands somewhere here. As we all know that this will be our cos component of initial speed, that is u cos 60, and it will be u sin 60. Done. If this is the projectile with respect to the ground frame, if this is the diagram with respect to the ground frame, everyone knows that the acceleration of the projectile along horizontal direction is 0 when we make the diagram with respect to the ground frame, isn't it? Because there is no any resistance due to the air. It's a well and versed idea about the projectile, a famous idea which everyone can notice, that there is a zero acceleration along horizontal direction. But when I draw the diagram of the projectile with respect to the train frame or with respect to the boy, and see here, if this is the u and if this is the u cos 60 and u sin 60, when I make the figure with respect to the boy or with respect to the train, basically boy is a part of the train. As train has acceleration, even one can say boy also has some acceleration a. Now once if he becomes observer, he makes his acceleration 0, because we all know in relativity observer feels as if he is at rest. So whatever the vector originally he possesses, he himself makes his complete and net vectorial property as 0. So to make his acceleration 0, for existing acceleration you need to add the opposite vector for both observer as well as for object. Okay, in this way. So now when when boy makes a comment about the particle, he says like along horizontal direction it has initial speed u cos 60 in I cap direction, and it has some acceleration along minus I cap direction, which means it's a biggest hint to say that he feels the boy feels that there is a retardation along horizontal direction because velocity vector and acceleration vector both are in opposite direction. Okay, so he said it is enough to make use of S is equal to ut plus half at square formula relative to the person or relative to the boy in this way. And already I mentioned that boy will make a comment that it is enough to travel this distance to catch the ball being inside the train. So relative distance is 1.15 meter. So in this place I can write 1.15 and relative initial speed is just u cos 60, that is cos 60 is 1 by 2, and even u value is 10, which is given in the question itself. So I can say 10 cos 60, 10 cos 60 is 5, directly let me write it as a 5. And the time is nothing but the time taken by the projectile to land from here to here, I mean from projected point to landing point. See, with respect to the ground frame or with respect to the boy, there is no any difference in analyzing or in making the analysis of vertical motion, because the boy or the train has a horizontal vector, and horizontal vectors do not influence anything regarding the vertical motion. Hence, time of flight will be same in both the frames. That we know 2u sin theta by g, which will be 2 into 10 into sin 60 root 3 by 2 by g is 10. Totally I will be getting time of flight root 3 seconds. Okay, so in this place I can write capital T, which is root 3 plus half. Relative acceleration is simply acceleration of the train A into root 3 whole square. Okay, and the value of 5 into root 3 will be, and we already calculated in the earlier video, it will be 8.65, and I can make the other terms continuation as it is. Now 1.15, 1 second here, as the acceleration of the particle projectile is along minus direction or opposite to the vector, actually it is under retardation, so one have to be clear with the symbol. This will become minus here. Okay, and it will be minus. Now if you send 8.65 to that side, and you will be getting some 3a by 2 here, and this value will be equivalent to 7.5, which is equal to 3a by 2. And as our target here is to find the acceleration of the train, the main target is to find acceleration of the train, so that is here a value will be equivalent to 15 by, because 7.5 into 2, 15 by 3, it will be 5 meter per second square. Okay, so the person who have some better idea about the relativity can also do this problem like this by analyzing the projectile path or projectile motion with respect to the train frame or boy. Okay, hope so you understood this relativity method also. Thank you.